9.2c, we're going to use a confidence interval to draw a conclusion for a two-sided test about a population proportion. Sometimes if a free response asks you if there's convincing evidence, you may be able to choose if you want to actually do a test or a confidence interval. I'm going to show you when you would have that option. And it would happen when you are doing a two-sided test. Remember, on a two-sided test, if you just think about it, if the answer is not equal to a particular proportion, what a two-sided test technically means is you're finding this for the p-value. However, think about what a confidence interval means. A confidence interval means what are the values in between these two z-values. So in essence, they're kind of are going to give you the same answer, but just in a different roundabout way. So I want to talk about how you can approach a problem like it. Let's look at Benford's law. When an accounting firm audits a company's financial records for fraud, they often use a test based on Benford's law. Benford's law states that the distribution of the first digits in many real-life sources of data is not uniform. In fact, there is no fraud. About 30.1% of the numbers in a financial records begin with the digit 1. However, if the proportion of first digits that are 1 is significantly different from 0.31 in a random sample of records, then the company does a much more thorough investigation of the company. So suppose they took a random sample of 300 expenses, and the financial record result in 68 of them actually begin with the digit 1. Should they do a more thorough investigation? So what would be a good hypothesis for this? Well, let's just go ahead. They don't talk about a significance level. Let's choose a 5% significance level for alpha. Now, our null hypothesis is the true proportion is 0.301. But we think it is different than that, is the best hypothesis for this case. So a two-sided test. Let's define P as a true proportion of expenses that begin with the digit 1. Now, the test we're going to do is we're going to do a one-sample z-test for P, and P's already been defined. Randomness from here, it said a random sample of expenses was selected, so that's done. For normalcy, n times p naught, our sample is 300, our p naught is 0.301, and that is greater than or equal to 10, as is the probability of failure meets that same requirement. And then for independence, in this case, it is reasonable to assume that there are more than 33,000 expenses for this company's financial records. And we have to show this because they are not doing replacement in their sample. For the due proportion, let's show p hat and the actual test statistic. So p hat in this case is 68 over 300 or 0.227. Our test statistic would be our p hat minus p naught over the standard error of that. So we have a p-value of negative 2.78. Now remember, it's a two-sided test. So in this case, if we do a sketch, our actual distribution would look something like this. So the mean, or p naught, was at 0.301. We're coming up with this test statistic, but it's two-sided, so we also mean this. Now to find the p-values, it's going to be these two shaded regions. So to do the p-value for that, if you do it by hand, what we're going to do is we're going to find, you could do normal CDF, you could find it for this region, and then you can just double it, or you could find it for this region and double it. I'm going to go ahead and do normal CDF for this region, which is going to show me this particular p-value here, so 2 times that. And again, lower bound, upper bound, the mean is 0 and 1. And when you do that and then you double it, you get a p-value of 0.005. So from there, we can go ahead and make a conclusion. Conclusion is here. We can say, since p is less than our alpha, which is 0.0052 is less than 0.05, we reject the null hypothesis. And what do we conclude? That there is convincing evidence that the proportion of expenses that have first digit 1 is not 0.301. Therefore, they should probably do more analysis and investigate the situation. Now, I do want to go back and highlight one thing. The actual calculation of the p-value, again, we found was 0.0052. If you use the calculator and do the two-sided test, I will tell you the calculator will give you the double value. So you do not double it on the calculator. They actually give you the p-value of both sides combined together. So it's this and that on the calculator. This is a good review question of type 1 and type 2 error in its context from section 9.1. So in this case, what would be the type 1 error? Remember, type 1 error means we rejected H sub O when we should not have rejected it. So the type 1 error in this case, we had rejected this and made a conclusion that this was true when we should not have. The issue might be this, that you believe the true proportion of financial records beginning with a 1 is not 30.1, so you suspect fraud and investigate. But the problem is everything's probably okay and there isn't fraud, but we're sitting here wasting our energy and we're going to investigate further when we don't want to or don't need to. Now what about a type 2 error? Remember, type 2, we fail to reject and we do not conclude this. So we failed to reject this when we should have. So what would be the type 2 error? Well, a good way to say this one would be you cannot reject H sub O, that the true population of 30.1 of financial records begins with 1. So you do not suspect fraud. Well, if we don't suspect fraud, we don't investigate, but we should have. Which one of these two do you think would be a bigger error to make or more severe? A type 1 or type 2 in this case? Well, we would say the type 2 is going to be a bigger issue here because we would fail to inspect for fraud when it actually exists. Yes, type 1 would be bad and that we'd be wasting our money and doing an investigation we did not need to do, but type 2 could be even more severe. Now remember at the beginning of this video I said instead of a two-sided hypothesis test, we could construct a confidence interval instead. What advantage would it be to actually construct a confidence interval versus doing the test? Well, a significance test only allows for rejection of H sub O, while a confidence interval actually gives us ranges of values consistent with the sample. So if you think about it back to our picture, here's what we had for our picture of our normal curve. Now for the hypothesis test we did, we were just able to see about our p-values. But the nice thing is if you construct the confidence interval is going to give you this range of acceptable answers, and you're going to get some numerical values associated with it. What's the connection between the test and the confidence interval? Remember on here, we rejected H sub O. So if you reject H sub O, and you conclude H sub A in this case, what does that mean of a confidence interval? Remember, rejecting H sub O means our p-value is small. So the real answers are going to be out in here somewhere. So if the real answers are out in here because we rejected H sub O, do you think it falls within the confidence interval? Well, if you reject H sub O, when it will probably then not fall within the confidence interval, is what that would say. And that should make sense because the p-value is out here, outside of this actual confidence interval. So if you were to really fall outside of the confidence interval, then that might say do only a two-sided significance test because the interval in that case may not really give you any more information. Last question here, why aren't confidence intervals always used then since it gives you some numerical values? Well, if you just need an answer of yes or no, then really a hypothesis test is going to be sufficient. But if you need to know something about quantitative answers and what the values may actually be, then you would want to use a confidence interval. So you don't always have to use a confidence interval. And for a one-sided test, sometimes the confidence interval is harder for people to actually interpret because it doesn't necessarily connect one-to-one as a two-sided test would with its confidence interval. So let's go back to the Benford's law example, and I want to show you how you actually could have done this with a confidence interval. So for the state portion, what you could say is we want to estimate P, which is the true proportion of expense that begin with the digit 1 at a 95% confidence level. Remember, we chose an alpha of 5%. And when you do an alpha of 5% on an actual two-sided test, that 5% is all you can have, so it actually divvies it up half and half. So the tails in each case actually are 0.025 and 0.025 to get our full 5%. Now, what's in the middle part here, which would be our confidence interval, therefore, is the 95%. So to be consistent between the test and the confidence interval, you have to adequately state it's a 95% confidence interval. So definitely make note of this connection. This is very important. Okay, the planned part. In this case, it's a one sample, Z interval for P is our statement. The conditions, technically we've already tested them, but let's pretend like we've never done it before. If you haven't done it before, then you do have to state them the first time. We know it's a random sample. Now careful, the normalcy on this one for the confidence interval doesn't use P naught, because we don't have P naughts only with hypothesis tests. It's P hat. So in this case, n times P hat, we're going to get 68 and then 232, both greater than or equal to 10. They are not doing replacing it, so it is reasonable, though, if our sample size is 300, that there's over 3,000 expenses. Now, the due portion. For the due portion on here, we have the formula written out for the confidence interval. Again, if I stated the one sample Z interval for P, I do not have to state this. We do, if we want to find the actual critical value for our confidence interval, remember on our confidence intervals, because we're 95% in between here, we technically have to go back and we are looking for all of this. So we have to do 97.5 at 0, 1 to get the true critical value. When we put that in here, then our critical value in this case is 1.96 related to this inverse norm. P hat goes in here and our sample size. The confidence interval, therefore, is going to come back to this actual value right here. So what we're seeing is this confidence interval coincides with this inner space right here. Now remember, in the hypothesis test, we said we reject H sub O and conclude it is not equal to 0.301. How does that coincide now with a confidence interval? Well, if you look at the confidence interval, we're trying to see is 0.301 within this confidence interval. And it is not within this confidence interval. So if our hypothesized value is not within the confidence interval, we would actually, again, say we reject H sub O and we conclude that it is different. And that's how you would use the confidence interval instead of a hypothesis test. So let's just go one other extreme. What if this was within the confidence interval? If our hypothesis value was within the range, we would say we failed to reject H sub O and we can't conclude that it's different because it's actually within our data set. So that's how that would work. Let's revisit the calculator commands really quickly. If you wanted to do this on the calculator, all we have to do for that is remember we're going to go this time again to stat, and we're going to go to our tests. This time we choose the 1 proportion Z interval. We're going to type in the 68, the 300. This should be 300, not 301, I believe, so there's a typo on my part. Confidence interval, and we're going to hit calculate. And we're going to see this is the answer. Write down the P hat on that one, which our P hat is right here. And the correct sample size of 300 and not 301. Again, let's formally talk about the conclusion then. So conclusion, we are 95% confident that the interval from 0.176 to 0.270 captures the true proportion of expenses at this company that begin with the digit 1. Again, we're going to make our decision. We already talked about this. Since this 0.301 is not in this interval, what we would say is that it is not a plausible value for the true proportion of expenses that begin with the digit 1. Thus, this company should be investigated for fraud. Again, you're going to end up making the same conclusion if you do the confidence interval versus if you do the test. This just gives us, though, a rough idea of where the possible values could be. One thing to keep in mind from the AP board, they're going to talk about absolutely, if it's a two-sided test and you're asked if you have convincing evidence, yes or no, you can either do the two-sided test or a confidence interval. They do not care. However, if it is a one-sided test and you construct a confidence interval instead, you will lose credit for that. So use the significance test only on a one-sided test. Do not use the confidence interval. Now, this is some extra practice, but it's also just some good computer output review. So on this, let's just look through it. It's a mini tab output, which is from the computer, from a significance test and a confidence interval for a restaurant worker, and a previously check your understanding. So explain what the confidence interval is, and let's just read the output. Now, I don't really remember the example per se, but let's just highlight a few things. On this sample here, you're going to see N, looks like capital N. It's actually the sample size, though, for mini-tab output. Here they say the sample P, that is the P hat. The confidence interval is actually very easy to read. It's right there. The Z value here is your test statistic you would have computed for your hypothesis test. And the P value is actually the probability P value we're looking for. Back to here, X, by the way, is your number of successes. And then if you look, you're going to notice here they actually did a test. So we didn't do this example before, so it doesn't really make sense. But just reading the computer output, they had H sub O where P is 0.75. And then they had H sub A is that it's not. So P is not equal to 0.75. So let's just even talk about it. If this is the computer output, and let's assume they're using an alpha of 0.05. For hypothesis testing, if the p-value is about 10.6%, we would say p is greater than alpha, so we cannot reject H sub O, and we cannot conclude that the alternative hypothesis is true. So how would you differ that with the confidence interval? Well, in this case, here's our confidence interval. And the true proportion we think is 75%. Is 75% in this confidence interval? It is. 75% is in this confidence interval. So if we just did a confidence interval, I'd say, you know what? This value is in the confidence interval, so I cannot reject H sub O and I cannot conclude H sub A. So either way, you're going to actually say the exact same answer. Here is what the book had said as a response. They said the same conclusion that we did. They did highlight this, which we've mentioned, is that the confidence interval, however, gives us more information and that we get a range of plausible values, where the hypothesis test just tells us to reject or fail to reject. So again, either way, we're going to fail to reject H sub O and we cannot conclude H sub A, but this interval does give us a valuable information about the true values of the data.